In the late 1920s, Thomas Midgley, working for DuPont, found that he could take simple alkanes and substitute fluorine and chlorine for the hydrogens and create a host of chemicals called chlorofluorocarbons. These were particularly useful as refrigerants and as propellants in aerosol sprays. Unfortunately, though, they weren't so good for the environment. It was found that they were linked to the destruction of the ozone layer, and later, in 1987, they were banned. They belong to a broader family of chemicals called the halogenoalkanes. Here's isomers of a halogenoalkane. First thing to identify them, the functional group is the presence of the halogen attached to a carbon, and that side group is called a halogeno. The presence of this halogeno group creates a very polar site on the molecule, or a dipole. That finds or allows other molecules to be attracted to that particular location, particularly solvents that are dissolved in water. This makes them far more reactive than alkanes, which are nonpolar. The presence of this dipole also changes their melting points and boiling points, making them slightly higher than their related cousins in the alkane family. And these can also be further classified based on the carbon that is attached to the carbon to which the halogen is attached. So in the first example, that's called a primary halogenoalkane, because there is one carbon attached to the carbon that's attached to the chlorine. Second one's an example of a secondary halogenoalkane because there's two carbons attached. And finally, a tertiary halogenoalkane. This is very similar to the nomenclature or identification that's used also with our alcohols. Let's look at some isomers of these chemicals. So here's the common molecular formula of all of the structures I'll go through below. C3H6Cl2. I'm going to start with putting the two chlorines on the end. Then I'm going to take the top carbon and move it over one position, and then move it over another position, creating three isomers. Now I'm going to begin by moving the carbon on the bottom chain over one. Now, careful examination of this molecule indicates that it's a repeat actually of one of the molecules I've drawn earlier. If I rotate that particular molecule, I can see that it's identical to the second one that I've drawn. So it's not an isomer. I'm now going to move the chlorine over one more position, and finally to a third position. Now again, careful examination of this molecule indicates by rotating it, I again have recreated what I had drawn earlier. So I'll remove those because they're not isomers. Now let's go through quickly naming these. First of all, they're all derived from a 3-carbon chain, hence they would all be called propanes. But what is different is the prefix in front. The first one would be called 1,1-dichloro, the second 1,2-dichloro, and the third one 1,3-dichloro. My final molecule with the two chlorines attached in the middle would be called 2,2-dichloro. The reactions that halogenoalkanes undergo is typically a substitution reaction. In particular, they call it a nucleophilic substitution. The word nucleophilic comes from positive loving. Remember that carbon tends to lose its electrons to the halogen that's attached, creating a partially positive charge. And this attracts what we call nucleophiles, substances that have negative charges. And examples would include the hydroxide or the cyanide ion. If we bring a hydroxide nearby, we produce an alcohol. You can see that the OH has been attracted to that positively charged carbon and then released the chlorine. I can identify it from the hydroxyl group that I've created, an alcohol. In a similar fashion, when I bring cyanide nearby, it too is attracted to that positive location, thereby producing what's called a nitrile. And I can identify nitriles by the presence of the C triple bond N group, called a cyano group. So those tend to be the major reactions that these undergo, nucleophilic substitution. So I hope you found that useful. And again, comments are always welcome. Thanks again for watching.